Structures influencing longshore sediment transport are those designs with the primary aim to change the longshore transport rates under both normal and extreme conditions in order to promote deposition. Example of these are groins. They are shore normal or perpendicular structures. Jetties, also known as shore normal breakwaters. Breakwaters, also named as detached shore parallel offshore breakwaters, and can be emerged or submerged. In many places around the world, we can find this type of structures with a variety of geometries, either individually, in a combination, or even all at the same time along a stretch of coast. On the Mediterranean coast, and particularly along Spanish coasts, it is possible to visualize a lot of these structures. For those who live in Yucatan, know that these structures are also very common since have been used to control erosion and provide entry to harbors and coastal lagoons. Until now, groins are the main hard engineering structures built for decades in Yucatan, sometimes causing more erosion than a solution to erosion due to the lack of proper design. The image shows a variety of shore normal or perpendicular structures nearby Yucalpatan Harbor. A variety of jetties and groins are observed in less than 1 kilometer. Let's see their characteristics, both positive and negative, and how they work. Groins are normally straight structures built perpendicular to the shoreline. They can have special shapes and can be emerged or submerged, or they can be constructed as single structures or as a battery of them. A field of groins is a series of these structures extending into the surf zone and spaced at relatively short intervals along a beach. They can be very effective in reducing the existing longshore sediment transport rate along a coast. By keeping the coastal sand trapped between two adjacent groins, they tend to stabilize the entire coast along which they are built. As such, they can be used to defend an eroding coast, for instance over a length of 5 kilometers. Two main types of groins can be distinguished. The impermeable groin, which are high-crested structures, with crest levels of 1 meter over the mean sea level. These types of groins are used to keep the sand within the compartment between adjacent groins. After construction, the shoreline will be oriented perpendicular to the dominant wave direction within each compartment, developing the characteristic sawtooth appearance of overall shoreline. Are impermeable, since they substantially reduce sand movement among them. The image depicts impermeable groins built along a stretch of Yucatan coast. Note the sawtooth appearance of the shoreline. On the other hand, we have the permeable. Permeable groins are low-crested structures with crest levels between the mean low water and mean high water lines or tidal datums. These types of groins are generally used on beaches with a small sediment deficit and where they're aimed to slightly reduce the littoral drift in the inner surf zone and to create a more regular shoreline, without sawtooth effect. Groins can be constructed using a variety of materials. For instance, are made from sheet piles or using a row of vertical wooden or steel piles purposely spaced in order to make a porous barrier, thus reducing but not totally blocking the longshore transport. The next image is the result of a numerical simulation showing the effect of two groins on the intensity and direction of currents and sediment transport, estimated in cubic meters per year per linear meter of coast. The incident waves are approaching to coast at a direction of 40 degrees with respect to the coastline. The warm-cold colors correspond to the bathymetry or sea bottom configuration. See how currents show with arrows are reduced by groins promoting sand deposition,